Hello friends, welcome to Radix, and in this session we will discuss remainder theorem. Now first of all, Euclid division lemma. Let's say we have a number like 437 and it is divided by 15. 15 2s are 30 and 15 9s are 135. So in this case 437 is known as dividend. This is quotient. This is divisor and this is remainder. So the basic rule given by Euclid, if we assume dividend as n, quotient as q, divisor as d and remainder as r, so Euclid says that n is equal dq plus r, and r is always less than divisor and greater than equal to 0. That part is very important. Say if we divide a number by 10, then remainder could be 0 1 2 3 4 5 6 7 8 or 9, right? If we divide certain number by 10, then remainder is always less than 10 and equal to 0. So all the number from 0 to 9 will be remainder, and when remainder is 0, this divisor is known as factor, right? Now one more important part, if we have this number 437, it is n, we can write it as 29 our quotient, divisor 15 plus remainder 2, right? So we can say that when we divide a number 437 by 15, it is divisible by 29 times and then 2 is remaining, right? So, and if we divide this number by 5, so one more important part, see if we divide a number by 5, 15, it is 5 3s are 15, remainder is 0. So if we divide a number by any divisor and that number containing multiple of this, remainder is always 0. So if we divide this number by 5, this 15 is divisible by 5, so this will give us remainder as 0, and finally we have remainder as 2, right? One more example, if we divide a number by 30, and given that when we divide a number by 30, remainder is 4, so we will write that number as 30q. Let there is quotient be q and remainder is 4, right? Now question would be, a basic question would be like this, that if we divide a number by 30, remainder is 4, so we will write that number by 30q plus 4, and then we have to calculate remainder when the same number divided by 15. So the process would be like this: 30 when divided by 15, remainder is 0 because 30 is a multiple of 15, so this entire value will become 0 and remainder would be 4. Now if we divide a number by 50 and given that remainder is 32, so we'll write number like n is equal 50q plus 32, and if we have to calculate remainder when the same number divided by 25, see 50 is divisible by 25, so what we'll do, this portion will give us remainder as 0, so we'll divide 32 by 25 and we will get our remainder as 7. So if in any question you have given with that remainder after division by a certain number, remainder is r, then we have to calculate remainder by another number. So the basic condition is that new number should divide previous divisor exactly. See if we have given with 50, when we divide a number by 50, remainder is 32, we can't calculate remainder when this number divided by 16, because 50q, we have no idea about q, it could be any value. So the second number by which we are dividing the previous number, this should divide the divisor, right? That part is very important. Now some question, when a natural number n is divided by 4, the remainder is 3, so number n would be 4q plus 3, And what is the remainder when n is divided by 2? Now if we divide this by 2, 4q is divisible by 2. So it will give us remainder as 0. And when we divide 3 by 2, remainder would be 1. Answer of this question is A option. Okay. Next. A number when divided by 280 leaves 115 as remainder. When the same number divided by 35, the remainder is. See, the number would be 280q plus 115. When we divide this, this is divisor, this is quotient, this is remainder. And we have to calculate when the same number divided by 35. See, 35 completely divide 280, so it will give us remainder as 0. Now, 115 when divided by 35, 35 3s are 105. Right, it will give us remainder as 10. Okay, B option. The remainder on dividing given integer a and b by 7 are respectively a 5 and 4. Right, so if we divide a by 7, remainder is 5, and if we divide b by 7, remainder is 4. So we'll write like a is equal 7q1 plus 5, b as 7q2 plus 4. What do you remember when AB is divided by 7? Now that part is very important. First of all, multiply these two, AB. This is 7q1 plus 5 and 7q2 plus 4. Now multiply this. This is 49q1 q2 plus 35q2 plus 28q2 q1 plus 20. Now, AB is 49q1 q2, 35q2, 28q1 plus 20. And now, when this number divided by 7, see, this is divided by 7 gives you remainder 0. This is divided by 7 gives you remainder 0. This is divided by 7 gives you remainder 0. So, finally, 20 when divided by 7 gives you remainder as 6. Answer of this question is D option. Okay. Next question. Two number when divided by 17 leaves remainder 13 and 11 respectively. Okay. A, let the first number be A. When divided by 17, let quotient be Q1, remainder is 13. Second number, let B. When divided by 17 leaves remainder 11. Now sum of these two. Now add A plus B. If the sum of those two number divided by 17, okay, this would be 17q1 plus 17q2 plus 24, and when divided by 17, this would give us 0 remainder, this would give us 0 remainder, and this 24 when divided by 17 gives you remainder 7. Answer of this question is C option. Okay. Next concept is successive division. Let's say we have a number like 263 and it is divided by 7. 7 3s are 21, 53, 7 7s are 49, remainder is 4. Now, successive division are those division in which we use this quotient as the next dividend, and let's say we divide it by 4. 4 9s are 36, remainder is 1. And then if we divide this quotient by 2, remainder is 2 4s are 8 1. So we will say that if a number successively divided by 7 4 2 respective remainders are 4 1 1. See, this is very important part, as in this case infinite number are possible which satisfy this condition. This 263 is one of them. Now the process how to solve question like this is this: we will write first of all divisor and their remainder 4 1 1. Now this is last division, and in this case this is divisor. Let quotient at last step is q, so this value will become 2q plus 1, right? As we have discussed in equivalent division, 2 is divisor, q let quotient, and 1 is its remainder. So 2q plus 1. Now this is quotient for this division. We can write it as 4 divisor quotient plus remainder 1, and now this value is quotient for this division, so we can write 7 plus 4, right? This is what our number. Now our number is 7 4 2q plus 1 plus 1 plus 4, right? Now in this case, if we multiply this 7 8q plus 4 and 1 5 and then 4, then 56q plus 35 plus 4, or we can write it 56q plus 39. Now in this case, value of q could be 0 1 2 3 4 up to so on infinity. See, there are shortcut also to calculate this number, but now if we take 0 as q, so our number would be q when 0, n would be 39. Now if n is 39, let us check this division. 39 when divided by 7, 7 5 ja 35, remainder is 1. Now 5 is quotient when divided by 4, 4 1 ja 4, remainder is, in this case 4, it is 1. Now when 1 divided by 2, 2 zeros are 0, remainder is 1. So same rule, 7 4 2, remainder 4 1 1. Now if we take q as 1, now if we take q as 1, we get n as 56 plus 35. This is 191. Now divide this 91 by this is 39. This is 95. 95 when divided 7 1 ja 7, 7 3 ja 21. See, remainder is 4. Now when 13 divided by 4, 4 3 ja 12, remainder is 1. And when 3 divided by 2, 2 1 ja 2, remainder is 1. This number satisfies several conditions. So removing all this, our n is equal 56q plus 39, where q is 0 1 2 3 4 and so on up to infinity. Now our condition is when divided by 7 4 2, remainder is 4 1 1. Now question may be asked like this: find highest number of 3 digit. Okay, so if we put value of q as 1 2 3 4, we will reach a point where we will get highest value of 3 digit. So what we'll do, we will equate this 56q plus 39 is equal less than 999. Okay, this is 56q is less than 999 minus 39. This is 06956q. So q would be 960 upon 56. Now 8 7 ja 120, 7 1 ja and 7 7 sub. So 17 point something. So q would be 17. So if we put q as 17, we will get our required number. So in this condition, we can calculate any possible number. Let's say we have to calculate, if we have to calculate total 3 digit number, yeah, if we have to calculate number of 3 digit number satisfying this condition, right? So what we'll do, if we put q as 0, we will get a 2 digit number 39. If we put q as 1, we will get again 56 plus 39 95. Now if we put q as 2, we will get first 3 digit number 56 into 2 plus 39, This is 112 plus 39, or it is 151. Now we have to calculate how many values are possible for 3-digit number. Let Q is 10, it will be 560 plus, see, if we put Q as 10, it would be 560 plus 39, right? This is 99599. It means it will go further. Now if we put Q as 20, number would be 56 into 20 plus 39, but it will be more than 1000. We have to calculate 3-digit number. It would be 1120 plus 39. So it is confirmed that number would be less than Q20. So let us take Q as, see, it is 159 more, or 160. So if we take 3 less, let's say we take 17, and would be 56 into 17 plus 39, right? It would be 952 plus 39. So this is 991. So number of 3-digit number start with Q2, then 3, 4, 5, 6, 7 up to so on 17, right? So if we remove 0, 1, there would be 15 numbers. See, from 0 to 17 we have total 18 number. If we remove 0 and 1, we will have 16 numbers. Okay, now solve some question on this. A number when divided by 3 leaves a remainder 1. When the quotient is, see, if this language, when the quotient is divided by 2, either in question successively division is given, or it is given that when the quotient is divided by 2 it leaves a remainder 1. So only 2 condition is given: 3 remainder 1, 2 remainder 1. Same process, we can write it this as 2q plus 1, this, and then 3 plus 1, our number. This is 6q plus 4, and what this is what our number, and we have to calculate what will be the remainder when the number is divided by 6. So when divided by 6, this will give us 0, remainder would be 4. Answer is B option. Okay, next question. Second question, a number when divided successively by 4 and 5, remainders are 1 and 4. So in this case we will write number as 5q plus 4 and 4 plus 1, right? See, we have to calculate when it is successively divided by 5 and 4. In that case we can write like this also. See, forget about this, cross multiply this, 4 4 is 16 plus 1. So we can write number as 17 as well. See, in this condition we have to calculate remainder when division done in reverse order, 5 4. So we can calculate direct number by using q as 0. See, if we use q as 0, it would be 4 4 is 16 plus 1. So using directly we get number as 17, right? Now 17 when divided by 5, remainder is 5 3 is 15, 2, and 3 when divided by 4, 4 0 0, remainder is 3. So answer is 2:3, C option. Okay, now applying the same concept in the next question, a number on successively divided by 9, 12 and 13, remainders are 2, 7, 9. So the process is multiply these two, it would be 108, then add 7 to it, it is 115. Now multiply 115 to 9, this, and add resultant to 2, this is 1035, and plus 2 1037. Now see the process reverse. 9 12 is 108, 108 plus 7 115. Now multiplied 115 with 9. So 1037 is our number. You can write number like this also: 13q plus 9, then 12 plus 7, then 9 plus 2. Right, and you will assume q as 0, you will get 1037. If you get q as 1, you will get another number. So 1037 is our requirement, because in this question we have to calculate remainder when division process done in reverse order. So first of all we will divide this by 13. 1037 divided by 13, remainder 13 7 is 91, 2 1 7, 13 9 ja 117, remainder is 10. So this is possible, right? No other option gives us 10, so no need to see it further. Answer is A option. N is a natural number such that when it is successively divided by 8, 6 and 10, it leaves a remainder of 5, 4 and 2 respectively. If n1 and n2 are the greatest and smallest 4-digit number which satisfy the above condition, then value of n1 and n2. Now that question is very important. We have given with n is a number which when divided by 8, 6 and 10 leaves remainder 5, 4 and 2. Okay. Now n would be 10 cube plus 2, 6 plus 4 and 8 plus 5. This is 8. 60 cube plus 16 plus 5 or 480 cube plus 128 plus 5 or 480 cube plus 133. Right. Now the important part is this: n1 is a smallest 4-digit number. So we can clearly observe that if we put q as 1, it would be 480 plus 133, which would be a 3-digit number. If we put n as 2, this would be 960 plus 133. It means, and it will become a 4-digit number. It means n1 we get when we put q as 2. So n1 would be 480 into 2 plus 133 or 960 plus 133. This is 391093. This is what our n1. Now n2 is very important. How to calculate n2? For that we need to calculate this is greatest 4-digit number. Now for that what we'll do, we'll write 480q plus 133 should be less than 100000, right? So 480q should be less than 7689. Now if we divide 9867 by 480, we will get q should be less than 20.5. It means for that q would be 20. Now n2 would be 480 into 20 plus 133. It would be 480 into 20. It is 9600. And 133, it would be 3379. So this is n2 and this is n1. We have to calculate n2 minus n1. This would be 9733 minus 1093. So it would be 0, 4. 40 is the last digit. Only option possible is A. Okay. That question is very important. See, in several questions, if we have to calculate a particular number, then we have to calculate q. And if we have to calculate remainders when divided by a certain number, then we'll apply direct method that we have discussed in previous questions, right? So this is the concept of successive division. There is one important result. Before this result, let's take some formula. If we have x square minus y square, it is x plus y and x minus y. If we have x square plus y square, it doesn't have any formula. Product formula, we have one formula, x plus y whole square minus 2xy, but there is no product formula for this. If we have x cube plus y cube, it is x plus y, one bracket, another x square minus xy plus y square. If we have x cube minus y cube, it is x minus y, x square plus xy plus y square. So what we have two important conditions. See, if we have minus between two numbers with same powers, here we have 2, here we have 2 powers, so it contain both x plus y and x minus y. Now if we have x cube minus y cube, both having odd power with minus in between, it contain x minus y, it doesn't contain x plus y. Now if we have odd power with plus sign, it contain x plus y, and if we have even power, it doesn't contain in any product formula. So the important part in this, the basic formula is this: if we have x to the power n plus y to the power n, it is divisible by x plus y if n is odd. That is very important. If we have x to the power n plus y to the power n, it is divisible by x plus y if n is odd. See, this is the case. Now if you know this formula, this logic is very important for you and very easy also. Now next condition, if we have minus sign in between two numbers with same power, now there are two conditions. One condition, this number is divisible by x minus y if n is odd. With this case, see, if power is odd, it contain only x minus y, and the second condition, it can divisible by x minus y as well as x plus y if n is even. This is the case. So if you have question like 23 to the power 11 plus 10 to the power 11. Now because we have plus sign with odd power, it is divisible by sum of these two number, or 33. So this number is divisible by 3, 11 or 33, right? Question may be like this: which of the following will divide this number? So your answer would be either 3 or 11 or 33. Now solving some question based on this. Now maximum number from the given option that will divide 7 to the power 12 minus 3 to the power 12 completely. Now see, we have to calculate maximum number. We have 7 to the power 12 minus 3 to the power 12. Now first logic, because these two are even number, this is divisible by 7 plus 3 as well as 7 minus 3. So it is divisible by 10 as well as 4, or it is divisible by their product also. So maximum number that will divide from the given option is 40, because a number divisible by 10 and 4, it is divisible by 40 always. Okay, next, 49 to the power 3n minus 16 to the power 3n is divisible by. Now important part is this, that n could be even or odd, right? So what we'll do, we will consider it as even. First of all, we will consider this n as odd. So if this is odd, n is odd, 3 into n would also be odd. So if odd number with minus sign, memorize that formula, x cube minus y cube, with minus sign in between an odd power, it is divisible by x minus y. So 49 minus 16, it would be 33. Now important part is this, that in that one option is there all of them. So we will consider this, we will check these two number also. So you can clearly see that this 49 is square of 7 and then 16 is square of 4. We can write this as 3n minus 4 to the power 3n. Means we got our answer as 33, but these two options are also possible. So we will check for them, and the process is this. Now 7 to the power 6n minus 4 to the power 6n. Now what we can do, we can write 7 cube 2n minus 4 cube 2n. Now 7 cube is 343, okay, to the power 2n, minus 4 cube is 64 to the power 2n. Now whatever be the value of n, this number is always even, and we know that if x to the power n minus y to the power n divisible by x plus y as well as x minus y if n is even. So this number divisible by 343 plus 64 and 343 minus 64. This is 70407 is there. Now if two options are possible, then third will also be there, and answer would be D. Now 139 or 7 279. So all of them is the answer. We have 22 cube plus 24 cube plus so on, 86 cube plus 88 cube, and divided by 110, the remainder is. See, first of all, 22 and 88, x cube plus y cube is divisible by x plus y, or 110. So we got that this two number will give us remainder 0, then 24, 86 will give us remainder 0. Now the point is this, that if we have even number of terms, then we can make pairs, and there will be we can make pairs of numbers and there will be no leftover. Means from even number we can select two number which will, when divided by 110, will give you remainder as 0. But if there are odd number of terms, if we make pair of 2 like this, 88, 22, 24, 86, then 26, 84, we can make pair. But if there are odd number, then one middle number will be left over, and then we have to divide this by 110. So first of all, we will check how many terms are there, starting with 22 and with 88 plus n minus 1 into 2. This is 66 divided by 2 n minus 1. So n minus 1 is equal 33, n is equal 34. So there are 34 terms. So it will leave 0 remainder because every pair will be divisible by 110. Answer is C option. Okay, that question is very important. We have odd powers, right? So this number divisible by 127 plus 97. Odd power with plus, we can divide this by sum of these two number, 224. Answer is A option. Okay. Now that question is very important. Find number of factor less than 100 for the expression 2 to the power 120 minus 1. Now how to solve this question? We have 2 to the power 120 minus 1, and we have to find all the factors less than 100 which will divide 2 to the power 120 minus 1. See, case 1. This is 2 to the power 120 minus 120. We can write 1 to the power 120. Means 1 to the power anything is always 1. It is divisible by, because even power it is divisible by 2 plus 1 and 2 minus 1. This is 3 and 1. Now second condition. 2 to the power 60 minus 1 to the power 60. We can write this as 4 to the power 60 minus 1 to the power 60. It is divisible by 4 minus 1 or 3 and 4 plus 1 5. Case 3. 2 to the power 3 to the power 40 minus 1 to the power 40. This is 8 to the power 40 minus 1 to the power 40. This is divisible by, because even power both minus and plus, 7 and 9. Fourth. 2 to the power 4 30 minus 1 to the power 30. This is 16 to the power 30 minus 1 to the power 30. This is divisible by 15 and 17. Then fifth part, 2 to the power 5 to the power 24 minus 1 to the power 24. This is 32 to the power 24 minus 1 to the power 24. It is divisible by 31 and 33. Then sixth case, 2 to the power 6 to the power 20 minus 1 to the power 20. It is 64 to the power 20 minus 1 to the power 20, divisible by 63 as well as 65, because we have positive values. Seventh case, 2 to the power 8 to the power 15 minus 1 to the power 15. Now this is very important. 2 to the power is 128 to the power 15 minus 1 to the power 15, because we have odd power, so it is divisible by only their difference, 127, right? And 127 is a prime number, so we need to calculate number less than 100. So we'll not consider this case. So we have remaining with this cases only. See, we'll write number 1, 3, 5 is there, then 7 is there, then 9 is there. See, 11 is there. Yes, 11 is there in this. So 11 is there. 13 is there? No, there is no 13. Yes, 13 is there in 65. 15 is there. 5 and 3, or 15 is there. So it is 15. Then 17. 17 is there. 9 is not there, right? So it will not divisible by 19. Now 21. Now 7 3s are 21 is there. 23 is not there because there is no number containing 23. 25. Only 1 5 is there. See, this 1 5 is there. 65 is there. We can't say that it is divisible by 2 times 5. So we can't take 25. Now 27. It is divisible by 9 and 3. The important part is this: a number is divisible by 9, hence it is as well divisible by 3. But if a number is divisible by 9 as well as 3, we can't say it is divisible by 27. See, we have 18. This 18 is divisible by 9 and 3, but this is not divisible by 27, so we can't write 27 here. A number should be divisible by 27 when it is divisible by 9 and 3. after division by 9, that remaining number should be divided by 3. Then only it is divided by 27. Now 29 is not there, 31 is not there, 33 is there. See, 33 is there. 35, 7 5 ja. Then 37 is not there, 39. 13 3 ja. See, 13 3 ja. 39. 41 is not there, 43 is not there, 45 9 5 ja. Yes, 45 is there. 9 and 5. 47 not possible, 49 is not possible because single 7 is there. 51, 17 3s are, yes, 51 is there. And then 53 is not possible, 55, no, 11 is there. 11 5s are 55. We can multiply like this. Then 57 is not possible, 59 is not possible, 61, 63 is possible, 65 is possible, 67 is not possible, 69, 23 is not there, so 69 is not possible. 71, 73, 75 is not possible because 75 required 25, 25 is not there. 77, yes, 77 is there, 11 7 ja. 79 not possible, 81 not possible, 83 not possible, 85, 17 is there, 5 is there, so 85 is also there. 87, no 29, so no 87, 89, 91, 13 7 ja, 91 is there. 93, 31 is there. If 31 into 3, 93 is possible. Okay, 95, 19 is not there, so 95 is not possible. 97 is not possible. 99 is possible. 911, yeah. So these are the number less than 100 which will divide this number completely. Actually, this is not a question. This question cannot be asked in examination, but the logic behind this is very important. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So there are 24 number less than 100 which will divide 2 to the power 120 minus 1. Right? Okay. Now this is very easy question. Find number of factor less than 50 for the expression 2 to the power 140 minus 1. So we'll apply same process. 2 to the power 140 minus 1 give divisible by 3 and 1. Now we can write 2 to the power 270 minus 1 to the power 70. It is divisible by 4 to the power 70 minus 1 to the power 70 or 3 and 5. Then 2 to the power, we can't write 3 here because 140 is not divisible by 3. We can write 4. 4 3s and 4 5s, 1 to the power 35. Now this is 16 to the power 35 minus 1 to the power 35. Now 35 is odd and with minus it is by their difference 15. Now then 2 to the power 5 minus 1 to the power 28. This is 32 to the power 28 minus 1 to the power 28. Now it is divisible by, because this is even number, it is divisible by 31 and 33. Now 2 to the power 6 is not possible, 7 will be more than 50. So we'll take only these two conditions, 1, 3, 5, 11, 15, 31, 33. Okay, and other than, there is no other number which will divide this. So there are 7 numbers. Now this question can be asked in an examination because there are less probability, less condition are there. So this type of question can be asked, right?